we're going to look at specifically graphing a translation of a wave. So these two functions here, sine and cos, are wave functions. They essentially create this effect. They both are very similar on the graph. The only major difference is where they start on a graph, right? When we translate, we know that our A value, is going to deal with anything vertical. That's a stretch or a compression. So we say vertical stretches, compressions, and technically flips too. And C is also vertical, but it's positive for up and negative for down. Our K value is horizontal stretches, compressions, and flips. And our D value is horizontal negative for right and positive for left, assuming you're using the operation also. If you pull it out, it's kind of the opposite. But we usually just look at whatever the simplified version is. And then the exact same thing is for the cos wave. So they've given us two questions. One is sine, one is cos. It'll be important that we can tell what A, K, D, and C are for both. But what we'll start with is whenever we're making a translation, we're essentially making it from y is equal to sine theta or x, whatever you want to call it. We use y and x because the graphs are usually labeled y and x, or y equals cos x. So let's make sure we can kind of lay those out. For sine, we go right through the origin at sine x, right? It goes up to 1 at 90, back down to 180, 0 at 180, down to negative 1 at 270, and then 360. And this is considered one period of the wave. And then you would just kind of continue this pattern as you go. So back up to 1, and then vice versa. So kind of plot it out. Are you guys okay with these major points?
Yeah.
It makes sense? Okay, good. So this is y equals sine x. Okay, let's do cos in red. Cos, the only difference, think of it like it's a sine wave that has just been shifted left 90 degrees. And this point starts here, but then continues the exact same pattern. Well, that was pretty good. Oh, except for that. That pretty much follows the exact same pattern. So we'll plot these points out too. You know what? Actually, let's do sine translation, and then we'll do the cos one right after. That way it doesn't get too confusing. So when we go to look at this, so we have our stretches and compressions. And I usually actually suggest to do both of those first. It doesn't technically matter the order. You can do the shifts left and right, but I personally find those easier, especially if the stretches and compressions are already done. Okay, so the first thing we need to do is actually take a look. Do we have all these values? And we do have an A value. Our A value is 2. Our K value we have, but it's not been common factored out. Okay, so I know we use x here, but it's actually in front of the variable, which they call theta. What we need to do is we actually have to common factor it out. And what that means is we have to take that 1/2 out of the theta and the 90. Okay, so I'll do a little math down here on the side. So that'll look like this. Y equals 2. 1/2 theta, is it minus 90? Yeah, plus 90. And then plus 2.
Oh, so divide them both in half?
Kind of. We're dividing both by half. And I really should write in sine because...
So then 90, would 90 become 180?
Yes, exactly. Yeah, so that's going to make a big change here.
Okay.
Sine is 2. So the only real difference here is you're going to get sine is equal to 2, or y is equal to 2 sine, 1/2 bracket theta, and then when you divide 90 by 1/2 or by 0.5, you get it with positive 180. So it increases in size there, that D value. And then the 2. So the A and the C aren't affected. The K is pretty much the same. It's the D that has a big change to it. Okay, so now we can really see what the true value of the D is. The A, the K, and then finally the C value. So with those being said, we're going to stretch it. The good thing about vertical stretches is all of your zeros, they don't change. They all stay in the exact same spot. Okay, so if we just were to do an A stretch, we're going to take whatever our major coordinates are, so 1 and -1, and I'm just going to multiply it by that 2. So 1 times 2 is 2, so that means we're going to reach a peak of 2. And then -1 times 2 is -2, so we're going to reach a trough of -2. The zeros, you still go through the zeros, because if you multiplied 0 by 2, you'd still end up with 0. Okay, so all of our values that kind of peak and trough, and I guess I should zoom out a little here. View. Let's try 100. That's better. All of those are going to be exaggerated. So, let's see if I can freehand this. It's going to look much more vertically stretched. Okay? clearly not very good at this. But there you go. So that's for the a value, okay? The k value, we take that half and think about each of these x values. So we're going to refer to the x values. So we're no longer focused on the y. K deals with the x values. And what we're going to do is divide by that value. So anytime you divide by something like a half or a third, it's the same as multiplying by 2. Okay? So our 0 times 2 is still 2. So that coordinate did not change. We're still going through the origin. Our 90 times 2. Well, 90 times 2 is 180. So this new coordinate here shifts over to 180. Okay? And this is where we're getting a horizontal stretch. It's kind of the opposite idea of A.
This is where I get confused, because then isn't the translation 180 to the left?
Oh, this isn't a translation yet. We're just going to pull it wider.
Oh, yeah.
And I'll show you what that would look like if you just see it like smoothly.
Okay.
The next one we'd use is 180. 180 times 2 is 360. So this 0 goes all the way over to 360. And it's pretty much already off our page. It's starting to do this.
Yeah.
Okay, so much wider than before. And then the same thing happens here. This goes to 180. This 180 goes to 360. And it's much wider than it was before. Okay, so this is a much wider look. I know when there's so many graphs it gets confusing, but we're now with the blue one. So we've done A, we've done red, we've done blue. 180. Because it's a positive, we take everything to the left. So we can take all of these major coordinates, and we have 1, 2, 3, 4, about 5 of them now. And we're going to shift everything 180 to the left. So this 360 pretty much falls off the page. This negative 180 goes over to 360. Okay. This 0 goes over to negative 180. This 180 goes over to 0. 360 goes over to 180. And if we kind of just continue the pattern here, we can kind of figure out where our next one's going to go. Because it's relatively symmetrical. Our negative 360 is going to be down here again. If we had another value out here, we could shift that to the left and you could see what it would look like. And it's going to kind of just turn up and turn up. So again, it's really overlapping. It's getting confusing. We can get rid of the other ones. That's the D. And finally, the C value is, remember on the green one now, the C value, everything's going to shift up 2 units. Okay, so we take all of our Y values and just move them up 2. And that's actually going to take it off this page. I wish I built it better.
Oh, I think it's down 2.
Oh, is it negative?
Yeah.
In the question? Okay, so negative.
We're here 4, right?
Yeah, you're
Then
right.
yeah, negative.
Okay, so it's negative. Either way, it's going to shift everything down 2. So this one coordinate is going to end up at negative 4. This 0 is going to end up at negative 2. Okay.
I might have to do it like this on the test.
Yeah, sometimes it takes it like that. The 2 will end up at 0. This 0 will end up at negative 2. And when you have so many lines, it may be helpful to erase some of them after. And this would be negative 4. So it has something that looks like this. And instead of doing our cos one, because this is the exact same, I'm going to show you this moves on like a graphing calculator, okay? So if our regular was sine x, okay? And then we knew our whole function was sine, is it a half x minus 180? Is that what we said? No, plus.
Oh, yeah,
plus, and then subtract 2. Okay, so we'll turn that one off, and we'll just kind of go one at a time here. We'll call this a sine x. So we'll get a slider for a, and the a value is going to be the value of 2. So as we move it up to 2, you can see how it stretches to where it is. Okay, so this is a stretch from the old version. The next function we'll put in is a sine, we're going to do a k value, right? So k x, and we'll put a value for k. Now our k was going to go down to a half, so as we go downwards, you can start to see how it gets wider and wider. All right, I almost got it. I'll go down to 5. So do you see how it stretched it wider now? So it's much wider looking. So we'll turn the old 2 off here. No, we need that one. Turn these ones off. Okay, and then from there, a sine k, we did the d movement, right? So minus d, put a slider for d. Now I need my d value to actually go up to 180. Maybe start at 0, let's say. Okay, so as we shift it, okay, and actually we need it to become negative 180. And the reason it has to go to negative 180 is because when you plug negative 180 into there, a negative and negative will be a positive. So we're actually going the other way, right? So this is where we're making that shift leftwards. And when we shift it all the way to negative 180, we've now moved it over from our peak at 180 here to a peak at 180 here. We've moved it 180 degrees. Okay, so the x value has changed to 180 degrees. And then finally, the last one is sine k x minus b plus c. And the c value was -2, so as we move it down to -2, let's get there. My hand isn't steady enough for this. Yes, yeah, got it. There you go. And that's what the final one looks like, which is exactly what we had, except we had all of the other graphs on top of it. That's why it looks so very confusing. But there is the final one. You see how it kind of overlaps it there. Okay.